Now I'm going to briefly look at some worked examples of how fractions are represented in binary using fixed point. Floating point comes in year 13. So in fixed point we have the concept of a point. It's not a decimal point because we're not working decimal anymore. So we have a point and we have a number of bits. Now the bits will be represented as a single stream of bits, but the way we calculate it will know where the decimal place is, so we can forget about that for now. In this example we're going to have 2 bits for the whole number, and we'll have 4 bits for the fractional part of the number. So I'm going to start off by representing 1.5. So I'm going to represent 1, which is simple. So the way we go in binary is we do a half, 1/4, 1/8, 1/16, 1/32, 1/64, etc. down. That's how we represent with the bit pattern. So we're going to do 1.5, so I simply put in a 1 in the column for a half and zeros after that. So this is how I represent 1.5 or 1.5 in decimal. Now I'm going to represent 2 3/4. So 2 is easy enough. 1, 0. And 3/4. How can I represent 3/4? Well, if I put 1 here, then I get 1/4, but I want 3/4. So what is a half? Well, a half is 2/4. So I have 2/4 and 1/4 makes 3/4, then 0, 0. And that's how I represent 2 3/4. Once again, we have number 2, and then we have a half, which is 2/4. We know this because 2 goes into 4 2 times, and 1 times 2 equals 2, so that's 2/4. You have to go back to your basic arithmetic for that. So we have 2/4 plus 1/4 is 3/4, and that's how I represent that. So let's try another number. I'm going to try 3 5/8. 3 should be easy enough by now. 1 and 1 in this column. So how do I get 5/8? Well, there's 1/8. And how many 8s do we get in a half? We get 4, because 2 goes into 8 4 times, and 4 times 1 is 4. So that's 4/8 there. And we have 0 and 0. 4/8. 4/8 plus 1/8 is 5/8. So 3 5/8 are represented in this way. Another example. I'm going to go for 1 3/8. So here we go. 0, 1. So we now have a 1 represented, and we need 3/8. So let's get 1/8. And we need 2 more 8s. So where can we pick up 2 more 8s? Well, 1/4 is 2/8. 4 goes into 8 twice. 2 times 1 is 2, so that's 2/8. 2/8 and 1/8 is 3/8. So I put a 0 in here and a 0 in here. So I have 1 and 3/8, and that's how it's represented. So in using these combinations, I can make fractions. Of course, fractions can also be converted to decimals when converting to a base 10 number, and that's how we represent fractions. A worked example of how to represent fractions in binary. Thank you.